Now we are considering this a plus b into a complement into b complement, and from the distributive property of this multiplication, from the associativity property of this multiplication binary operation, we can write this a plus b into a complement. Here we have written that very a plus b into a complement into b complement into b complement. And we also know that this multiplication binary operation is commutative. So a plus b into a complement, we can write this is equal to a complement into a plus b, and into b complement remains the same. Now we are using the distributive property of this multiplication over addition. So this is equal to a complement into a, we have written here a complement into a, plus a complement into b, we have written here plus a complement into b. This is this first part. So this we have written into b complement into b complement. A complement being the complement element of a, from the complementation law or property, we know a complement into a, this is basically equal to 0, plus a complement into b into b complement into b complement. Now 0 being the additive identity element, 0 plus a complement into b, this is equal to a complement into b complement into b complement. So a complement into b complement. Now again we are using the associativity property of multiplication. So this is equal to first a complement into b into b complement. This is b into b complement. And this b complement being the complement element of b into b complement, this is actually equal to 0. So we have written here. So a complement into b complement, this is equal to a complement into 0. And 0 being the additive identity element, a complement into 0, this is equal to 0. So what we have obtained, a plus b into a complement into b complement, this is equal to 0. So we have written here a plus b into a complement into b complement, this is equal to 0. And we have also proved that a plus b into a complement plus b complement, this is equal to 1. Now try to remember what was the definition of a complement element. If you add with any member from the Boolean algebra with its complement element, the resulting value would be equal to the multiplicative identity element 1. And if you multiply the very element by its complement element, the element by its complement element, the resulting value would be equal to the additive identity element 0. So a plus b into a complement into b complement, this is equal to 0, and we have also shown that a plus b plus a complement into b complement, this is equal to the multiplicative identity element 1. And we also know that the complement element of an element in a Boolean algebra is unique. So what can we conclude from these two? We can conclude that a complement into b complement is the complement element of a plus b. That means a plus b whole complement, this is equal to a complement into b complement. And the second proposition being the dual of the first one. Why? Because in place of addition binary operation we have placed this multiplication, and in place of the multiplication binary operation we have written this addition binary operation. So this is the dual of the first proposition. So we can prove this proposition also similarly using the same postulates of Boolean algebra. Okay, these two propositions are called the De Morgan's laws. Okay, thank you.